Classify these salts as acidic, basic, or neutral. So we want to remember that the term salts refers to ionic compounds, and to determine the impact of these salts or these ionic compounds dissolving in water and the pH, we've got to remember the rules for how ions affect the pH. So let's review those rules. First, the conjugate bases of strong acids do not impact the pH. We're going to look at the ions that do not impact the pH first because it's just a handful, and all other ions will impact the pH in some way. So the conjugate bases of strong acids do not impact the pH. Chloride, bromide, iodide, nitrate, chlorate, and perchlorate do not impact the pH. Now, some textbooks will oversimplify the dissociation of sulfuric acid, and they will state, or they will assume, that sulfuric acid completely dissociates to 2 protons and the sulfate, and in that case sulfate would not impact the pH because it would be the conjugate base of this very strong acid, and it has no desire to accept back a proton, so it won't affect the pH. That's actually not the case. This is an oversimplification, and what really happens is sulfuric acid goes through 2 dissociations. The first dissociation goes practically to completion. So for every mole of sulfuric acid, we're going to get a mole of proton as well as hydrogen sulfate. Now, hydrogen sulfate will dissociate to a much larger extent than most weak acids. It's actually a kind of strong weak acid, but there is an equilibrium here. So sulfate is actually the conjugate base of a weak acid. It's not the conjugate base of a strong acid. So this sulfuric acid, its diprotic nature, makes it a little bit more complex than the monoprotic strong acid. So I just really wanted you to be aware of what's actually happening. Now, your textbook actually acknowledges that this happens, but in some circumstances this is not acknowledged, and this oversimplification is used to just really simplify matters. The other set of ions that do not impact the pH are the conjugate acids of strong bases, the alkali metals, as well as the alkaline earth metals that form the strong bases. So this is not a complete list of the alkali metals, but it's the most commonly used alkali metals. So any alkali metal will not impact the pH, and neither will calcium, barium, or strontium. Alright, so now let's take a look at the ions that will impact the pH. One very easy pattern is all cations are acidic, except for the conjugate acid of the strong bases that we just reviewed. But all other cations are going to be acidic, so it doesn't matter whether it's a transition metal cation or a polyatomic cation, all cations are acidic. Anions that are the conjugate base of a weak acid tend to be basic. So here's an example: nitrite, fluoride, these are basic. And the reason I say they tend to be basic is if we have an anion that has an H+, then it can be an acid or a base. And so determining whether this anion that has a proton on it acts as an acid or a base, we've got to compare the Ka and the Kb of the acidic and basic properties. And we'll go through this in more detail so that will make more sense. But a Ka times a Kb has to equal 1 times 10 to the minus 14th. And we might need to use this to calculate the Ka or the Kb of an anion that has an acidic proton. So let's look at the hydrogen sulfate ion. This has an acidic proton. If we look at its Ka value, we see this is a relatively large Ka value for a weak acid. But as an anion, it can act as a base as well as an acid. So let's take a look and remind ourselves of how ions can act as an acid or a base. If we're looking at hydrogen sulfate acting as an acid, it's going to donate its proton to water to form hydronium and sulfate. That's what this Ka is for. The basic behavior, if it acted as a base, it would accept a proton from water to form sulfuric acid and hydroxide. Now we know that sulfuric acid is a strong acid, and so it is going to dissociate. There is no tendency for this bisulfate to accept a proton to form sulfuric acid again. And this high value of this Ka means that that hydrogen sulfate is going to act as an acid in water. All right, so let's look at another example. Another anion that has an acidic proton is bicarbonate. And we look at, sorry about that, I realized there was a little typo here and I wanted to correct that. So let's look at bicarbonate. It has an acidic proton, and if it acts as an acid, it's going to donate a proton to water to form hydronium and carbonate. The Ka for this equilibrium is 4.8 times 10 to the minus 11. Now, bicarbonate can also act as a base because it's an anion and accept a proton. And when it accepts a proton, it will form carbonic acid and hydroxide. The Kb for this process is 2.2 times 10 to the negative 8. So when I compare the two equilibrium values, I see that the Kb is much larger by about 3 orders of magnitude than the Ka. So this is the equilibrium behavior that is going to dominate with bicarbonate acting as a base. So anions that have an acidic proton, we have to do a little extra work to figure out if that anion is going to be an acid or a base. If there's no acidic proton and it's not the conjugate base of a strong acid, then it's going to be basic. However, if it has that proton, then we've got to do a little bit more work to figure out which of the two behaviors is going to be favored. The acidic proton, where it donates a proton to water, or the basic behavior, where it accepts a proton from water to form hydroxide. Okay, so let's go back to our problem. I look at KCl. K, potassium, is an alkali metal that will not impact the pH, and chloride is the conjugate base of a strong acid, hydrochloric acid. So this is going to be neutral. Neither ion will impact the pH. Ammonium bromide. Ammonium is a cation, and it's not the conjugate acid of a strong base, so this is going to be acidic. Let's look at bromide. Bromide is the conjugate base of a strong acid, so it will not impact the pH. So ammonium, as a cation, is going to be acidic. Let's look at lithium bromide. Lithium is an alkali metal. Lithium is the conjugate acid of a strong base, so it will not impact the pH. And bromide is the conjugate base of a strong acid, so it will not impact the pH. Neither ion is going to impact the pH. Let's look at sodium fluoride. Sodium, alkali metal, will not impact the pH, but fluoride is the conjugate base of a weak acid. How do I know that? Well, it's not the conjugate base of a strong acid, so it's got to be the conjugate base of a weak acid. So it has to be basic. There's no troublesome proton there, so we don't have to do anything except identify this as the conjugate base of a weak acid, and we know it's basic. Here we have potassium sulfite. Potassium does not impact the pH. It's an alkali metal, and sulfite is the conjugate base of a weak acid. And again, how do I know that? Well, it's not the conjugate base of a strong acid, so it has to be the conjugate base of a weak acid. So it's going to be basic.